Good day, everyone. Today, we are gathering here to talk about a very interesting and relevant topic, word recognition using audio in Kichwa. Who are we? We are graduate students from Escuela Superior Politécnica del Litoral, my college Jonathan Santana, our tutor engineer Ronald Criollo, and I, Karina Ortega. Have you ever wondered how many different languages are spoken all over the world? According to UNESCO, there are around 7,000 different languages on the planet. One of them is Ecuadorian Kichwa. Kichwa Runashimi belongs to the northern Kichwa branch, that is Quechua too. And to a greater or lesser extent, it is also spoken in other Andean countries such as Colombia, Peru, Bolivia, Chile, and Argentina. In Ecuador, it is spoken in 9 of the provinces of the Sierra and throughout the Amazon basin to the east of the Andes. Kichwa has been implicitly and explicitly recognized as the predominant indigenous language of the country and has a great influence on the rest of the Amazonian language. So my question for you today is, did you know that there are indigenous languages in danger of extinction? Well, as we can observe on our map, the Ecuador region is marked, and it shows that there are languages that are endangered, seriously endangered, and critically endangered, according to UNESCO Atlas data. In fact, every year, around 26 languages disappear, according to the United Nations. This means that we are losing our linguistic and cultural diversity at an alarming rate. And this is because other languages are being adopted, since less than 35% of indigenous people speak a native language upon finishing school. Less than 5% speak their ethnic language upon finishing high school, and less than 2% express themselves in their own language upon completing university. Personal growth must also be inclusive and resilient. But now let's see with Jonathan the effort to preserve endangered language.
In India, for Khattari language, they developed a post-speech tagger it's built with the help of the hidden Markov model and the better algorithm of obtaining an accuracy of 86.84%. In the Italian, for Latin language, the objective was to classify 32 Latin phonemes. They perform a feature extraction approach experiment with 8 different training classifiers. The classifier obtained an accuracy of 86%. In Colombia, Cauca, for the Kichwa language, they developed an educational mobile application of a technology proposal. Includes basic language concepts in communication, such as rating, color, animal, weather, etc. Next. In Ecuador, for the Kichwa language, they developed a tool called Rachina that consists of web module and desktop application, and it for automatic translation from Ecuador Kichwa to Spanish. SEAL International is an organization whose main purpose is to collect and disseminate documentation of the lesser-known language. Precisely on this platform, we found audio resources, such as documents explaining the teaching of the Kichwa language of Salazar in Ecuador. Next.
Therefore, the objective has been set that technology can be very useful in the preservation and promotion of these languages, which motivated the development of a word recognition model in Kichwa, using audios to use it in voice recognition applications and alert system activation. The methodology used is as follows. First, collect audios in native Kichwa. The SEAL organization authorized the use of this dataset, which contains short audio recordings of words recorded by a woman from the Salasaga population belonging to the Tungurahua province in Ecuador. From there, new audios were created with 3 different voices to increase the number of audio. 3 two-syllable words were selected whose intonation used the affricate phoneme Chusu, Akcha, Chaki. Then, through the Edge Impulse platform, the features are extracted and the model is trained to finally deploy on the CLVL Sense and Nano 33BL Sense boards. As for the technology used, we have the Nano 33BL BLE stands for, the CLBLE stands for. How did we do it? Through the Edge Impulse platform, audios from 5 classes were loaded, such as 2 minutes Wakta, 2 minutes Chaki, 2 minutes Chusu, 2 minutes 60 seconds for noise, and 8 minutes for other conversations in Kichwa. Regarding training, the current classification model was used with 80% data for training, 20% for testing, with 300 epochs in the number of cycles.
The motivation. The dominance of a smart device have enabled remote or autonomous control in some areas of service for people. For example, is in her car. Audio recording is an essential component that this device analyzes by detecting voice activity and classify into identity so events like count hit in human speech. However, this device results in frequent false positive when distinguishing in human speech from other some events. That's it. Its performance is limited to a controlled environment for a specific application. One study found the device yield false positive result for no voice, 16% or 14%, while maintaining a high level of true positive for speech, 89%. Therefore, it's important to note that the false positive rate in voice recognition alert system can have important sequence. Next.
So based on the motivation to contribute to the preservation of these minority languages and the need to improve the effectiveness of voice recognition alerts, it has been considered to build this model with keyword in Kichwa language, with the objective of reducing false positive and being able to be used in cases such as an application that was developed to prevent possible femicides by activating emergency voice alerts. For example, it is important to ensure that the alerts reach the people who will provide timely assistance in case of aggression. These people will receive text messages and calls requesting necessary help. What benefits are obtained? First, greater inclusion and accessibility. 2, improvement in the effectiveness of alerts. And 3, a strengthening of cultural identity. As a result, an accuracy of 96.8% was achieved in the training phase, and the 94.12% in the testing phase.
This test is with the Xiao sense. First, we detect with the word in Kichwa Wakcha. We have an accuracy of 0.99, which the word Chaki and it has an accuracy of 0.91. And finally, the word Chusu, which 0.99 accuracy. Then, with the Nano 33 sense in the same way we tested with the word in Kichwa, Wakcha. We have an accuracy of 0.94. With the word Chaki and it gave us an accuracy of 0.92. And finally, the words Chusu, which accuracy of 0.98. We have seen that when capturing the words, the nano device took a few seconds longer than the Xiao 2 identity dent. However, the model works with both boards. We have detected that with the word Chusu and Wakcha, there is higher percentage and accuracy. The example we consider a future step that we could continue to improve the model and make it as reliable as possible, creating a larger data set with those words.
Future work. Our intention for the future is to execute more than 1 or 2 models such as a gender classification model, sentiment classification, or speaker identification model, which will allow us to know the situation or environment in which a person is in need of timing assistance. And deploying these models on microcontroller using TimeML technologies such as the NICLA voice board. 2, learning and strengthening the Kichwa language, and security and surveillance.
Conclusion and recommendation. 1. Increase the size of the dataset. 2. Explore different machine learning algorithms. While the current approach was successful, it may be benefits to explore different machine learning algorithms that can further improve the accuracy of the model. 3. Collect data from different dialects. Kichwa has several dialects, and collecting data from different dialects can improve the accuracy of the model in recognizing words from out of them. 4. Test the model in real-world scenarios. And finally, it recommends to test model in real-world scenarios to assess its performance and identity any area for improvement.
Thank you for your attention.